My name is Muhammad Rizal. Today I want to present about the project of the numerical programming lab 4 from the group 2 of sections 5. Okay, this is the group member. The first group is Nur Maizatul Kibria binti Abdul Maulud. Second is Nurul Azizah binti Adri. The third is Lubna Naziha binti Mat Lajis. And the fourth is Muhammad Muzammil bin Muhammad Rizal.
Hi, Assalamualaikum. My name is Lubna Nazah binti Malajis. My matrix number is DE22093. So I will explain about the introduction of this project. So firstly, the objective of this project is to design a MATLAB simulating programming for analyzing the electric circuit in figure 1 using MATLAB simulating software. So we can say that this allows users to learn the MATLAB simulating programming technique as well as circuit analysis technique. Okay, next we move on to the problem statement. There are 3 problem statements for this project assignment. First is, how can the difference of input voltage amplitude affect the response of capacitor's output voltage? For the second one, how can the difference of input voltage frequencies affect the response of the capacitor's output voltage? And the third one is, the ACRC electric circuit shown in figure 1 is a low pass filter. So we move on to the next presenter. Thank you.
My name is Muhammad Muzammil bin Muhammad Rizal. My matric number is DE220172. Today I want to present about the objective of the project. The first objective is to provide understanding on MATLAB simulating programming technique. Second is analyze the output voltage over time and the change of the frequencies affect the system behavior. The third is understanding the low pass filter. Numerical programming is a crucial component of scientific and engineering research, incorporating the application of mathematical algorithms and computational methods to address intricate problems. It empowers researchers to analyze data, simulate physical phenomena, and arrive at well-informed decisions through quantitative analysis. MATLAB also came with an add-on that significantly needed to do the experiment, which was MATLAB Simulink, which is a widely used software tool in the field of engineering and science. It is enabled for engineering and researchers to model up, simulate, analyze systems in this graphical and visually programming environment. Simulink is also provide a visual interface where user can construct model by connecting blocks representing various block diagrams and components to simulate this literal system. This simulation can be similarly as the block diagram in the computer programming, where we need to rearrange the certain commands block or component to execute the circuit. Simulink offers a vast array of pre-built blocks that represent different mathematical operations, physical components, and signal techniques. This block can be interconnected to create complex models that accurately represent a real-world system. It has the ability to stimulate the system across multiple domains, such as mechanical, electrical, control system, and more. It can be used as powerful visualization tools that allow users to observe the dynamic behavior of their models in real time. Okay, next for the next presenter.
Hello and Assalamualaikum. My name is Nur Maizatul Kibria binti Abdul Maulud. So I'll present my part, which is the simulations. Firstly, you need to use MATLAB Simulink to create the circuit. To find the component, you need to click on the Simulink library and select SimScape Electrical. Or if you know the name of the components, you can directly search the name of the component at the search. For AC voltage source, you need to change the voltage amplitude to 20 volts, for the frequency 50 Hz, and for the phase shift to 90 degrees. Then for the resistor and capacitor. Next, you need to connect all the components. Set the resistor value for 470 mega ohm and the capacitor 47 nanofarad. Then we need to put a voltage sensor to get the value of voltage in and voltage out. Then for the solver configuration is used to give a solver setting info for the simulations, and don't forget to put the PS simulating converter also. Then we need two LCD display to display the value of voltage in and voltage out for the results. Lastly, we need to put the scope to show the sine wave for the circuit. For scope setting, you need to click at the view and choose layout and choose two boxes. Then you need to click the configuration properties, click display. For display 1, change the title to input voltage versus time and Y label to voltage input. The same goes to display 2, change the title to voltage output versus time and Y label to voltage output. Okay, for the results, we need to change the voltage and also the frequency value, and we need to observe the difference between.
At a low frequencies, an RC low-pass filter has minimal effect on the input signal. The output waveform closely resembles the input waveform with negligible attenuation and phase shift. When the frequency of the input signal is much lower than the cutoff frequency, the reactance of the capacitor becomes relatively large compared to the resistance. The capacitor acts as an open circuit in this low frequency band, allowing the signal to travel through with no resistance. The output voltage will roughly match its input voltage with minimal attenuation. The phase shift caused by the RC filter is also minimal at low frequency. The waveform of an RC low-pass filter output closely resemble the input waveform with minimal distortions or attenuations. For high frequencies, an RC low-pass filter significantly attenuates the input signal and introduces a noticeable phase shift. When the frequency of the input signal is much higher than the cutoff frequency, the reactance of the capacitor becomes relatively small compared to the resistance. The capacitor acts like a short circuit in this high frequency band, effectively sending the input signal straight to the ground. The outcome is an attenuation of the RC circuit output voltage, which becomes more pronounced the farther away the frequency is from the cutoff frequency. The phase shift that the RC filter introduced become more obvious at high frequency. The output waveform lags behind the input waveform when the phase shift is typically negative. The waveform of an RC low-pass filter output will be significantly attenuated and may exhibit distortion and rounding. In conclusion, an RC low-pass filter is a simple circuit that allows low-frequency signal to pass through while attenuating higher frequency signals. It is commonly used to remove high-frequency noise or unwanted signals from a system. The cutoff frequency of a low-pass filter indicates the frequency region in which the filter is transitioning from low attenuation to significant attenuation. The RC low-pass filter significantly attenuates high-frequency components of the signal while allowing low-frequency components to pass through with minimal attenuations. The RC filter introduces a phase shift to the output signal, particularly at frequencies close to and above the cutoff frequency. The phase shift is typically negative, causing the output waveform to lag behind the input waveform. At high frequencies, the RC filter can introduce distortion and rounding of the waveform due to the capacitor's lower response time compared to the rapid changes in the input signals. Passive low-pass filters are used in audio amplifiers and speaker systems to either minimize high-frequency noise or hiss-like distortion, or to route lower frequency bass signals to the large bass speaker. When applied in this way, the low-pass filter is commonly referred to as a high-cut or treble-cut filter in audio application. That's all from our team. Thank you.